Here are the solutions to quiz 3-4. Some more practicing. Step one is if we can factor it. Number one, there's nothing factorable. So the domain comes from the denominator. So that's what x, the 0, the opposite number. The range we're going to skip right now. The x-intercept comes from the numerator. Now this is actually going to be a fraction in that form. So if we work backwards, we would actually subtract 3 and divide by 2. So the 0 that's there, the x-intercept's negative 3 over 2 or negative 1.5. A little tricky. The y-intercept. When you plug in 0 for x, it's the last number divided by the last number. That's negative 1. The vertical asymptote from the denominator. The horizontal is by taking the power terms. So the power term on top and the power term on the bottom, when you divide, the x's cross out and you're left with y equals 2. S is slanted. We don't have a slanted asymptote because the degrees are the same. You can't have both a horizontal and slanted, and nothing crossed out for a whole. So this is what we're going to graph. I'm going to start at negative 1.5. There's a point. I'm going to go to negative 1 on the y. There's a point. My asymptotes are at 3. So 1, 2, 3. There's my line, and the horizontal is at 2. There's my line. So you can already tell I need another point there, but I'm going to connect these two and then curve it and curve. So I got one curve using those 2 points. I need a point here to curve here in this corner. So I'm going to take the number that's next to the asymptote. So this asymptote is at 3, so I'm going to pick 4, the one right beside it. So I'm going to go 2 times 4 plus 3, and then 4 take away 3, and then solve it. So 2 times 4 is 8, plus 3 is 11. It's a little bit off my graph, I think. Does this count to 8 or 11? 1, 2, 3, 4, 5, 6, so it's 8. All right, let's do another one then. So that's way a little bit off my graph. So why did I try 5? So 2 times 5 plus 3, and then 5 take away 3. So that gives me 10 plus 3, 13 divided by 2, 6.5. That'd be easier on the graph, right? So go to 5. What did I do? I did 5 and 6.5. 2, 3. And now I have a point to curve through. So if something is way off your graph, then keep going. Do the next one beside that one, or 6 or 7, until you find a point to curve through. The range is what y can't equal. So for this one, that's the horizontal asymptote, which is 2. All right, let's look at number 2. I'm hoping you're practicing first and that you're not just copying the video. So I'm going to need a factor. When I look at the numerator, factor out to 10, and you're left with x plus 2. When I look at the denominator, this is a one-step diamond. So 2 numbers that multiply to 8 and add to 6, or 4 and 2. I can tell that x plus 2 crosses out. That means there's a hole, and I'm left with 10 over x plus 4. So this is my last fraction, fully simplified. I know it's blurry. There it is. So let's see what we can get so far out of this. I'm going to start with this last fraction in the numerator. There's nothing that will make the top 0. It will always be 10. There's no letter left at the top to solve for. So we have no x-intercept. If I take the last number, which is 10, divided by the last number, which is 4, 10 divided by 4, like 5 divided by 2, it's 2.5. So I do have that on my graph to go to. My vertical asymptote, the opposite number from the bottom, is x equals negative 4. The horizontal, I want you to notice the denominator is more powerful than the numerator. So when I look at the power term on top and on bottom, the bottom is more powerful. It has a bigger exponent. So whenever that's the case, the horizontal is always at 0. We have no slanted. We do have a hole. So what crossed out? What's the 0 of what crossed out? That's the x coordinate. And then to find the y coordinate, I plug it into this last equation. So I plug in -2 for x, and then I solve it. So that's 10 divided by 2, and that gives me the answer 5. So that's the y coordinate of the hole. So I'm going to put that on my graph. So -2 and 5. And the asymptote x equals -4. And 0. All right, so I already have 2 here I'm going to connect. So the y-intercept in the hole, I'm going to connect and curve. I need a point here to curve. So the vertical asymptote is at -4. I'm going to pick a number to the left of that. So I'm going to pick -5. And I'm going to plug it in to solve here. So 10 over -5 plus 4. So that's going to give me the answer -10, which is above my graph, or below my graph, I mean, in terms of curving. So I'm going to pick another number. So if I picked the next number, -5, the next one could be -6. If I want 10 divided by -6 plus 4, that's -5. So that's better on my graph. So I'm going to go to -6 and -5 because it fits on my graph. So -6 and -5 is on my graph. -5 and -10 would have been off my graph. And then I curve using those points. So the domain, the asymptote, and the x coordinate of my hole, the range, the asymptote, and the y coordinate of my hole. And that's it. All right, try number 3. The numerator is a one-step diamond. That's -4 and -3. Nothing crosses out, so that's it. So my domain comes from the denominator. It can't be 2, and that's my vertical asymptote. My x-intercepts are +4 and +3. My y-intercept, so the last number divided by the last number, that's -6. Let me put the vertical asymptote is at 2. Now, there is no horizontal asymptote here because the numerator, the power term on top, is bigger than the bottom, so we have to divide. So I'm going to do synthetic. So I'm going to take +2. When you do synthetic, do the opposite number, and then 1, -7, and 12, and then divide. I don't need the remainder, so this gives me the line, which is y equals x minus 5. There's no holes because nothing crossed out. So I start at -5. And I go up 1 over 1. And there's my slanted one. And then I'm going to draw it. Now the picture over here, -6, -5. I like everything that I see. I know what I don't like seeing. I was confused. You know what was confusing? These 2 points made it confusing because apparently I don't know the difference between negative and positive numbers. So that's -3 and -4. So where should I have gone with those points? So let's pretend I didn't do that. Is at 3 and 4. So start in the middle, 1, 2, 3, and 4. Now the graph is coming together. So when I looked at it, I was trying to figure out the shape of the graph, and the shape was not coming together because they were off. Now, maybe that's a good lesson learned, right? If a point is off, if something doesn't feel right, can you go back and figure out, I made a mistake somewhere, and I looked and I said, wait a second. That should have been +4 and +3. I was in the wrong location. That's much better. So using this point, the ends go to the asymptote. So it's going to have a curve so that both arrows go to the asymptote. Same thing here. This is going to the asymptote. It'll cross a little. And then same thing. So one end goes here, one end goes there. And you have your graph. All right, good lesson learned, I hope. Number 4. All right, we're going to graph it. So can you press pause and graph, or try and challenge yourself? So we're going to factor out a 3. We're going to factor out an x, and then that's a simple diamond. So 6 and 5, the two numbers are 2 and 3. So I'm going to go 2 and 3. Yes, something crosses out. So I have 3x, x plus 2. So that's my last fraction. So if I look at the numerator, no letters, nothing will make it 0. There's no x-intercept. If I try to solve for the y-intercept, I don't have any 2. In fact, the last number I don't see here at the end for the denominator is 0. And I can't go 3 divided by 0. It's undefined. There's actually no x-intercept and no y-intercept. We'll deal with that in a moment. There is a hole. So what crossed out was x plus 3. So the 0 is -3. We're going to take -3, and we need to plug in to find the y coordinate of the hole. So x becomes -3, and then you solve. So -3 plus 2 is -1. A negative times a negative is +3, and then when you divide, you get +1. So -3 and +1. That's a hole. All right, asymptotes. We have 2 zeros on the bottom. X by itself is 0, and then -2. So we're going to put those on the graph. So -2 and 0. Because we have 2 vertical asymptotes, we have 3 pictures. On the left, a picture in the middle, and a picture on the right. We have a horizontal asymptote. I want you to notice the numerator and the denominator. The denominator is more powerful. So then it's always y equals 0. There's no slanted. So at y equals 0, I have another asymptote. So one part of the picture I can do. So using the hole, I can draw this part of the picture. But now I need a point in the middle and a point on the right. So there's really only one obvious number to plug in to find a point in the middle, and that's at -1. So to the last fraction, I'm going to plug in -1. So it's -1, -1 plus 2. So that gives me -1 times +1, and that is a negative answer. So I'm going to find where -1, -3 is, and then I'm going to curve here. Remember, both ends go to the asymptotes always. So this has this picture in the middle, this curve, as the arrows go to the asymptotes. It is not going to cross over. There's no x-intercepts at all. So the only direction the arrows can go is there. And then I need a number to the right here. So this asymptote is 0. So I'm going to pick 1, which is right beside it, and solve it. So to the last one, I'm going to go 1, and then 1 plus 2. And then solve that. So 1 plus 2 is 3, times 1, that's 3, and then divide. I get the answer 1. So 1, 1 is a point on my graph. So 1 to the right, and 1 up. And then I'm going to draw that curve as well. So here we have 3 curves, a sad face. You might feel sad that you have to graph this. And a hole. So a lot of fun puzzle, like a lot of stuff going on here, a lot of layers. So the domain, x cannot equal the asymptotes, which are 0 and -2, and the x coordinate of the hole, -3. The range, there's a bunch of stuff going on here. So I'm going to ignore the range. And the reason is, it's not just that y can't equal 0. There's a whole gap here between 0 and that curve. And here, this hole then is covered by that point on the other side. This would require a graphing calculator to try to figure out the range. I'm going to let it go. So x-intercept, y-intercept, slanted, nothing. That's the whole graph, and we graphed it. All right, number 5. Let's graph this. Graph it. Let's factor it so we can graph it. So last 4 times negative 5 and 8. So two numbers that multiply to negative 20 and add to 8. And then we have to divide. So we're going to divide by 4. Now, when I divide by 4, I got to reduce it down. So really, this is 5 over 2, and this is 1/2. So you have to reduce it down to lowest terms, then slide it. So we have 2x plus 5 and 2x minus 1. And then the bottom is 2x plus 1. Did I get my signs right? Yeah. All right. So no hole in this then. Just double checking, and I know this should be 2x subtract 1. These do not cross out. One's subtracting, one's adding. Double checking. All right, the domain comes from the denominator. So if I go back a step with 2x plus 1, like if I made it equal to 0 and go back a couple steps, so if I subtract 2, so if I subtract 1 and then divide by 2, I get the fraction, which is negative 1/2. That's what x can't be. That's my vertical asymptote, is negative 1/2. Why not? Well, let's see. I'll see what I want my scale to be. X-intercept on top is negative here, right? Negative 5 over 2, which is negative 2.5. Easier to graph with decimals. Negative 1/2 is negative 0.5. The y-intercept, the last number divided by the last number, that's negative 5. We'll just keep the scale at 1. So we have negative 1/2. Oh, our horizontal asymptote. Notice we need to do dividing here. In fact, I can't even do synthetic. I have to do long division. I can do that right here. So 2x plus 1 divided by 4x squared plus 8x, take away 5. So I'm going to do long division to find the slanted asymptote. So 4x squared divided by 2x. Divide it, and it's 2x, and then you multiply. So 2x times 2x, 2x times 1, and then subtract. Now this is as far as I need to go, because I just need 2 terms on top. I don't need to find the remainder. So I subtracted, what's 6x divided by 2x? That's 3, and it's over. So the line is 2x plus 3. So I'm going to start at 3. And then I'm going to go up 2 and over 1. So up 2 and over 1. All right, so those are my lines. One slanted, one is vertical. I don't have a horizontal or a hole. So my x-intercepts are at negative 2.5. And negative 1/2. No, see, that one's positive 1/2. Sorry. So I had to change the sign here. And because it can't be on top of the asymptote. So that's positive 1/2. So it's on this side. We have a y-intercept at negative 5. And we're going to connect these together and make our curve. So often when our oblique curves look like this, I want you to notice the entire curve from bottom to top covers all numbers. So the range here is all real numbers, the way the curve is. All right, we up for a challenge? Number 6, we got this. I'd love for you to try first, or just challenge yourself. Like, can you understand the concept of what we're doing? I know you can, if you have the time to think through it, right? All right, we're going to factor this. So we're going to factor out a 3x, and that gives me x squared subtract 4. I can do one more to that. I'll do it in a second. I'm going to factor out x. That gives me x squared minus 4x plus 3. We're not done yet. So x squared take away 4 is the difference of squares. When you square root, it's x plus 2, x minus 2. The denominator is a one-step diamond with negative 4 and 3. That's minus 1 and minus 3. And then, is there anything that crosses out? So the x actually crosses out. So because the x crosses out, the whole at x, or the 0 at x, is 0. So there's actually a whole at 0. So to find the y coordinate of the whole, I plug in 0 for x and solve it. So let's do that right now. 0 plus 2, 0 take away 2, 0 take away 1, 0 take away 3, and then I'm going to solve it. If I saw this, I see a negative times a negative is positive. I see the 3's divide out, and that gives me the answer negative 4. That's how I would solve it. So 0, negative 4. That means there's no y-intercept because there's a hole on there. All right, let's keep going. Our vertical asymptotes are the bottom, which are the opposite numbers. So that's at 1 and 3. So I'm going to do that. 1 and 3. We do not have a slanted asymptote. If I look at the power term on top and bottom, the exponents match. So when I divide, the answer is just 3. So I'm going to go to positive 3. And so I have my asymptotes in my whole. We're going to get this. What's left in the numerator? 3 does not give me a 0, but here, negative 2 and positive 2, those are my x-intercepts. So I went to positive 2 and negative 2. My y-intercept, I said I don't have one. So what we have, let's curve. So I'll start left to right. So I have a point and a hole. So I'm going to connect it with a curve, and then it goes and continues and finds the other asymptote. So the ends of the asymptote, it frames the picture on the one end. Here, this one's going to be confusing. I know it. So, for this picture in the middle, I want you to think back in terms of understanding that it's going to cross over, that these are odd multiplicities. So it crosses over. I want you to know, I'm going to back up. I'm going to just do my best here, and I know this is going to be tough. All right, take a moment here. That vertical asymptotes also have multiplicity. And an odd multiplicity means they go in opposite directions. Well, if they have an even multiplicity at that asymptote, they would be going in the same direction. So this curves down. The other one must go up because it's an odd multiplicity. And at positive 2, we have an odd one. So it's going to curve, it's going to cross, and it's going to keep going to the other end. And you're thinking to yourself, I just made up a rule. I just crossed over the horizontal asymptote. And here it is. You can cross the horizontal in the middle. The horizontal asymptote is set up for the end behavior. Vertical asymptotes you cannot touch or cross, like Ghostbusters. The streams can't touch. But the horizontal, you can actually cross over the horizontal. It gives you the end behavior. And if the curve is guiding you to, you can cross over a horizontal. I know. Like I just made up the rules as I'm going along here. And then the last one on the right side, what's this asymptote right here? 1, 2, 3. So to the right of 3 is 4. So we're going to try to see if 4 gives me a good answer. So I'm just going to do this quickly. 4, we have a 3. 4 plus 2 is 6. 4 take away 2, 4 take away 1, and 4 take away 3. So these cross out, and that gives me 12. That's way off my graph. Let's try 4. Did I do 4? Which one did I? Yeah, I just did 4. 5. So we have 3. 5 plus 2 is 7. 5 take away 2 is 3. So this one's too big, so I'm going to cross it out. 5 take away 1, and 5 take away 3. And I'm going to solve that. Nothing here crosses out. All right, so 9 times 7 is 63 divided by 8. So that's really close to 8. So 8 goes into 63 7 times, that's 56, and there's 7 remaining. So like if that said 64 over 8, the answer would be 8. So it's really close to 8. So I'm going to use that. So that's 5. And almost 8, which is right up here. And I'm just going to curve using that one. That is a fun graph. And by the way, let's say you think I just made it up as I went along. That's fair. Let's look at Desmos. And I'm going to type it into Desmos. So let's see what this is. So if I do Desmos here, and I type in that, it better equal, right, what I just said? I better have not just made this up. All right, so there's my equation. Interesting. See, look at this one here. See, this, Desmos has a hard time with this equation. So it recognizes the x-intercepts, right? But this line right here, man, it doesn't like it all. Because there's no x-intercept here, even though it's crossing. Like, this line should not exist. This is like the asymptote that they put in. But they normally wouldn't put in an asymptote. It's really interesting. So that's at, oh, I'm trying to think what that is at. So if I put in x equals 2, oh, not 2, where's the other one? 3. So if I said x equals 3, see, for some reason, it put an asymptote right there in red to represent that. So if I put in the two asymptotes, which are 3 and 1, you can kind of see the curve that's happening here. You see the curve that's happening here. And then we have an asymptote, and it starts upper left and really skinny coming down. This thing here shouldn't be happening. And then you have this curve here, which is the curve on the top right. We should have a hole at 0, -4. So right there, oh, I had it. There it is. At 0, it's undefined. Right there at 0, -4 is where our hole is. So it matches, but man, Desmos doesn't even like the equation. So that means we should be done, right? Anyways, I'm proud of you. You tried your best. There's a lot of parts moving on. You're challenging yourself. It's not easy graphing, but we're practicing it. We're trying to figure out how the parts go together. I'm proud of you. All right, Mr. G Math, over now. Till next time.